Last part of this unit is classifying quadrilaterals. We are going to focus on parallelograms, rectangles, rhombuses, and squares. So let's review their characteristics and what we know about those four quadrilaterals. So the general term quadrilateral means four sides. So we have a parallelogram, which with a parallelogram, it has opposite sides that are parallel and opposite sides that are congruent. It also has different properties that, or characteristics that are important but aren't necessary for it to be a parallelogram. For it to be a parallelogram, it has to have opposite sides that are parallel, and that's it. That's the definition. So to show that it's a parallelogram, you can either do slope and show that opposite sides are parallel because they would have the same slope, or you can do the distance formula and show that the opposite sides are congruent. A rectangle is a parallelogram, so it will also have opposite sides that are congruent and opposite sides that are parallel, but a rectangle specifically has four right angles. So if you suspect you have a rectangle, you definitely want to do slope to show that the consecutive sides, the sides that are next to each other, are perpendicular, which would mean that their slopes are opposite reciprocals. For a rhombus, also a parallelogram, so it's going to have opposite sides that are congruent and opposite sides that are parallel, but specifically it has four congruent sides. So you would definitely want to do the distance formula and show that all four sides are congruent. It's not a bad idea to go ahead and do slopes, because if four sides are congruent and then slopes are opposite reciprocals, then it's a square. So anytime I do quadrilaterals, I do both distance and slope because they're all types of parallelograms, so we need to see specifically what type of parallelogram it is. All right, so in our first example, we are given 4 points, so we are going to start by graphing them. We're going to look at it, make a prediction of what we think it is, and then we are going to do the distance formula. We're going to do our slope formulas, and we're going to make a conclusion based on that, because remember that it might look like something but be something else. So let's try to graph these points. A is -2, -1. B is 4, 3. C is 7, 0. And D is 1, -4. So now let me try to connect these. All right, so here's A, here's B, here's C, here's D. Connect, 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 connect. So again, like, this isn't the best picture because drawing on this is not great, and if I were drawing this on paper, I would use a ruler. My sides would look a lot better, so I think I would have a better idea of what it looks like. It does look like it might be a rectangle by looking at this, but we're going to make sure that we definitely find the slopes, because if it's a rectangle, it has to have right angles, which means you have perpendicular sides. So we definitely have to do slopes. I'm going to do both slope and distance to look and decide. Well, actually, we don't really even need to do distance because clearly those sides are not the same. So we can rule out square and rhombus. So let's just focus on the slopes then. So to do the slopes, you can do your slope formula, or I'm just going to count them. So I'm going to do the slope of AB first. I'm always going to start left and go to right. So if I go from A to B, I'm going to go up 1, 2, 3, 4. And then over 1, 2, 3, 4, 5, 6. So 4 over 6, or 2/3. Okay. All right, so now let's find the slope of CD. CD should be the same as AB, but let's verify that because we don't ever want to make an assumption. So I'm going to count from D to C. I'm going to go up 1, 2, 3, 4. So rise is 4. And then run 1, 2, 3, 4, 5, 6. So it is 4 over 6, or 2/3. Okay, cool. That doesn't show anything about it being a rectangle. All that's showing right now is that it does appear that it's going to be a parallelogram. So we'll know when we find the slopes of AD and BC, we'll see if we have opposite reciprocals. And if we do have opposite reciprocals, then we know that it is a rectangle. So let's find the slope of AD. So I'm going to count from A to D. I'm going to go down this time, 1, 2, 3. And over, oh, and since I went down there, that's -3, sorry. And over to the right, 1, 2, 3. So that is -3 over -3, which is -1. BC should have the same slope, but I'm going to make sure. I'm not going to make any assumptions. Start at B, count to Z. I'm going to go down 3 and then over 3. Okay, so we definitely can tell this is a parallelogram because the opposite slopes are the same, which means the opposite sides are parallel. Now, if we are comparing the consecutive sides, AB to AD, those are not opposite reciprocals. So they are not perpendicular, which means there are no right angles, and this is not a rectangle. So even though it looks like it possibly was a rectangle, it's not because there are no perpendicular segments. So ABCD is a parallelogram because opposite sides are parallel. And that is the true definition of a parallelogram. You could have found the lengths as well, but we knew the lengths weren't all four going to be the same, so it wasn't necessary. There would have been nothing wrong if you would have done it, but it just wasn't necessary. You really only need to find the lengths of all four sides if you think they might be the same length, so that you can conclude if it's a rhombus or a square. All right, for example 2, we've got the points. Let's try this again. -3, 3. Okay. 3, 0. 2, -2. And -4, 1. All right, let me label these A, B, C, D, and connect. So a similar shape to last one. It definitely doesn't look like a rhombus or a square. The lengths are definitely not the same. Looks like it could be a rectangle again, but last time we thought it was a rectangle and it wasn't. So we are going to do the slopes and we'll check out and see what happens. All right, so I'm going to start with AB. I'm going to start at A and count to B because I like to go left to right. So I'm going to go, remember it's rise over run. So I'm going to count down 1, 2, 3. So that's -3 over 1, 2, 3, 4, 5, 6. So that would be -1/2. All right, then I'm going to count the slope of DC. DC and AB should be the same because they are opposite sides and they better be parallel. Let's just count from D to C, go down 1, 2, 3, so down 3, and over 1, 2, 3, 4, 5, 6, so also -1/2. Okay, so that's supporting the idea that this is definitely a parallelogram, but we need to find the slopes of AD and BC as well. So AD, I'm going to count from D to A. So I'm going to go up 2 and over 1. Up 2 is positive, over 1 is positive, so that's +2. And then C to B, up 2, also over 1. Okay, so when you compare A to B and D to C, those are the same, so they're parallel. And the slope of AD to the slope of CB, they're the same, so they're parallel. That supports that it's a parallelogram. Now, if we look at the consecutive sides, AB and AD, those are opposite reciprocals, and so are CD and CB. So that means those are perpendicular, which means it is indeed 90-degree angles, which makes this a rectangle. So ABCD is a rectangle because there are 4 right angles. And again, the work is going to support your answer. Don't make that statement without showing me the work to support 4 right angles. Okay, so now let's take that example that we just did and let's find the perimeter and the area. Well, in order to find the perimeter and the area, I need to know the side lengths, and I didn't find the side lengths. So we're going to have to go back and do that. So let me scroll back to that picture. Well, actually, what I'll do is I'll just write the points out again, would be the best thing. So A was -3, 3. B was 3, 0. C was 2, -2. And D was -4, 1. So although I didn't need to find the lengths of the sides to determine if it was a rectangle, obviously I have to find the lengths of the side to find the perimeter and the area. So we only need to find the lengths of 2 of the sides since we know that the opposite sides are going to be the same. So I'm just going to draw a quick sketch just so we remember what this one looks like. A was here, then B, then C and D. So I'm just going to find the length of AB and the length of BC, and then we can go from there because AB and CD will have the same length, and so will AD and BC. All right, so AB. Let's do our distance formula. AB would be -3 minus 3 squared plus 3 minus 0 squared. So that would be -3 minus 3 is -6. -6 squared is 36. And then 3 minus 0 is 3, and 3 squared is 9. So that would be the square root of 45, which simplifies to be 3√5. Okay, so that's for AB and also for DC. Okay, now let's find the length of BC and AD. So BC would be 3 minus 2 squared plus 0 minus -2 squared. So 3 minus 2 is 1, 1 squared is 1, and then 0 minus -2 is 2, 2 squared is 4, 1 plus 4 is 5, so that's just the square root of 5. So BC is the square root of 5, and AD is the square root of 5. So to find the perimeter, I'm going to add those sides together. So √5 plus 3√5 plus 3√5 plus √5. So you could put this in exact if you wanted to. There's 1, 2, 3, 4, 5, 6, 7, 8 √5s if you add them all together. But you probably would want to know what approximate value that is, and that would be 17.9 units. And in case you're not sure where the 8 came from, I took the coefficients. There's a 1 in front of that, there's a 3 in front of that, a 3 in front of this, and a 1 in front of that square root of 5. So 1 plus 3 plus 3 plus 1 is 8. To find the area of a rectangle is base times height. So our base is 3√5, our height is √5, and whoops, √5, not 3. So if I multiply that, that will end up giving me 15 units squared. And again, you're always welcome to use a calculator, and you can also do the math mentally, right? If you multiply that, that's 3. 3 times 1 is 3, and then √5 times √5 is just 5. So 3 times 5 is 15. All right, let's look at another example. So again, we're given the coordinates, so let's get those graphed. We've got -3, 3, 3, 5, 5, -1, and -1, -3. All right, so A, B, C, D. Let's connect. Okay, so it definitely appears that the sides are all the same, making me think this could potentially be a rhombus or a square. So we definitely need to find the lengths of all the sides. But we're also going to need to find the slopes since it looks like it could be a square. It looks like those might be right angles. We definitely want to find the slopes. On this one, we're going to do both distance and slope. So a little bit more work on this one. So let's start with AB. So we're going to do -3 minus 3 squared plus 3 minus 5 squared. And I'm trying to, as we progress through this, show less and less work, just because for space and time it makes it a lot easier. So -3 minus 3 is -6, and -6 squared is 36. And then -3 minus 5 is -2, and -2 squared is 4. So 36 plus 4 is 40, and the square root of 40 is the same thing as 2 root 10. You don't need to put it as a decimal. You can if you want, but I'm just going to leave it as 2 root 10. I'm also going to do the slope at the same time. So I'm going to count 1, 2 is my rise, and my run 1, 2, 3, 4, 5, 6. So my slope is 2 over 6, which is 1/3. All right. Now let's go to BC. All right, BC, we're going to do 3 minus 5 squared plus 5 minus -1 squared. So that would be -2 squared, which is 4, and 6 squared, which is 36. So that actually gives me the exact same thing, 4 square root of 40, which is 2 root 10. So definitely at least looking like a rhombus based on that, since those two sides are the same length. Let's find the slope of BC, and let's see if it happens to be the opposite reciprocal. So to go from B to C, I'm going to count down 1, 2, 3, 4, 5, 6. So down 6. And then over 2 to the right, so that would be -3. So the slopes of AB and BC are opposite reciprocals, which makes angle B a right angle. So definitely looking like this is going to be a square. So I'm just going to finish up by doing CD and AD as well. So for CD, we have 5 minus -1 squared, which is 6 squared, and -1 minus -3 squared, which is 2 squared, 4. So yes, this is going to be 2 root 10 as well. And then the slope up 1, 2, and then over 1, 2, 3, 4, 5, 6. So also 1/3. So last one, AD. -3 minus -1 squared plus 3 minus -3 squared. So again, we get -2 squared plus 6 squared. So that is going to be root 40 or 2 root 10. And then the slope, count down 1, 2, 3, 4, 5, 6, and right 2. So down 6, right 2 gives me -3. So all of my sides are the same length, making it a rhombus, but then all of my slopes are opposite reciprocals, making those right angles, which then makes it a square. If you would have just done the sides and never checked the angles, you would not have been able to say this is a square. So it is important that if you think it's a square, that you do both. So ABCD is a square because all sides are congruent and there are 4 right angles. And, or you can say consecutive sides are perpendicular. You can say it a couple different ways. Again, make sure you have the work to support your statement. All right, so now we're going to find the perimeter and the area of that triangle. So I'm just going to make a sketch of what it looks like very quickly. We've got A, B, C, D, and all of the sides were 2 root 10. So to find the perimeter, we're just going to add 2 root 10 4 times. So you can do 2 root 10 plus 2 root 10 plus 2 root 10 plus 2 root 10, or you can just multiply by 4, which would be 8 root 10. But again, that doesn't make a whole lot of sense if you're talking about the perimeter, so 8 root 10 as a decimal is 25.3 units. Since it's a square to find the area, we do base times height. Our base is 2 root 10, our height is 2 root 10, 2 times 2 is 4, root 10 times root 10 is 10. That gives us 40 units squared. All right, last example, one more graphing. So -5, -2 is A. B is -1, 3. C is 3, -2. And D is -1, -7. A, B, C, D. Let's try to connect. Okay, not the best picture. But no, that's actually the connection on that one looks really bad. Let me try if I can see if I can do that a little bit better. Okay, so definitely looks like sides could be congruent. So I definitely want to use the distance formula. Maybe those are right angles, so we're going to do distance and slope just in case. So let's start with AB. So for AB, we have -5 minus -1 squared plus -2 minus 3 squared. You can become a distance formula expert with as many times as you're going to have to do this. So, all right, -5 minus -1, that would be -4 squared, which would be 16. And then -2 minus 3 is -5, and -5 squared would be 25. So 16 plus 25 is 41. Square root of 41 is just the square root of 41. Now let's find the slope. So up 1, 2, 3, 4, 5. Rise 5 and run 1, 2, 3, 4. So our slope is 5 over 4. All right, let's go to BC. -1 minus 3 squared plus 3 minus -2 squared. That's going to be -4 squared, which is 16, plus 5 squared, which is 25. So 16, 25, again, 41. For the slope, down 1, 2, 3, 4, 5. Right 1, 2, 3, 4. Down 5 over 4. Okay, so compare those two slopes. Are they opposite reciprocals? No, they're not. They're opposites, but they are not reciprocals. So be careful. Don't think that that means that those are perpendicular. They are not perpendicular, so we know that this is not going to be a square because there are no right angles. It does appear that all the side lengths are the same. Let me just finish by finding the length of CD and then AD. And then it looks like this is just going to be a rhombus. So 3 minus -1, that's that 4 squared again. -2 minus -7, that's that 5 squared again. So 16 and 25 is 41, so square root of 41. You can find the slope again if you want, but CD is going to have the same slope as AB, which would be 5 over 4. And then finally, let's knock out AD. We've got -5 minus -1. There's that -4 squared again. Plus -2 minus -7 squared. That is that 5 squared again. So again, square root of 41. So all four sides are the same. That means it's a rhombus. If we count the slope, it's -5 over 4. No opposite reciprocals, so no right angles. So this is just a rhombus. A rhombus because it has 4 congruent, sorry, this is so messy, sides.